of the implications of cosmic inflation I've read is that it implies that there could be a multiverse. What is a multiverse?
So I found that in order to define a multiverse, we kind of ought to define a universe first, because multi is just, uni is one, multi is many. So let's define what a verse is. And my definition of a verse is that we can make measurements of the universe, but in doing so, the way our universe is constituted, that as I look out in the universe, I don't measure the universe as it is, I measure it as it was some time ago. For example, when I look at the moon is about 200,000 miles away from us. Light travels roughly 200,000 miles per second. So I'm looking at the moon, and as I look at it, I don't see it as it is right now. I see it as it looked 1 second ago. And if I go to the sun, it's about 8.5 minutes. So if the sun were to go out right now, we wouldn't know for 8.5 minutes, because that's how long it takes the information to propagate to the Earth. And as I look further and further away, it takes longer and longer for light to reach us. So if we go out to the Andromeda galaxy, light takes 2.5 million years to get from the Andromeda galaxy to us, which means that, was astronomers take pictures of it, we're looking at the Andromeda galaxy and we're seeing it as it looked 2.5 million years ago. We go out to the Hubble Ultra Deep Field, we get things that are 10 and 11 billion years that the light has been traveling towards us. And so we continue to ask the question, how far away can we see where light has the time to get to us? And right now, and I think this may be, except for maybe with some gravitational waves, the most distant thing that emitted light, or the thing that emits light that we can see that is now the most distant from us, is the region that emitted the cosmic microwave background radiation. That's as far back as we can see in time. So, and that is actually right now located about 46 billion light years away from us, which is, enormous distances. But, as I go further and further away, it takes longer and longer for that light to reach here. Eventually, since the universe is only 14 billion years old, I run into a place where anything further away from that, I will never detect, or I cannot detect. And so what I like to define as the universe is the furthest reaches away from where we are, where light can reach us and we can measure something. And so we'll just call that the observable universe. At that point in time, I can now talk about the multiverse. The multiverse is just anything beyond that. And so that's really the simplest way to define, or in my assessment, the simplest way to define our universe is the furthest reaches where we could possibly see, and then the multiverse is just any physical realm beyond that.
So sometimes the proponents make it sound, or the YouTube proponents make it sound like there's duplicates of our universe, kind of like the many worlds interpretation in quantum mechanics, that the inflation is creating these new pocket universes that then grow on their own, etc., and that our universe is part of an eternally growing multiverse. Is that kind of different from what you're saying, or the same?
Well, so now that if we define our observable universe, and then the multiverse is anything out there, the question is, what kinds of, are all multiverses the same? And it turns out no, all multiverses are not the same. And I love Max Tegmark had this nice delineation that I like to use. It's so in our universe, if you were to be instantaneously transported to the edge of our universe, you'd see more stuff out there. And in all likelihood, it will look statistically just as the same as the stuff inside our observable universe. And so it's kind of the Star Wars type multiverse, if you will, a galaxy a long time ago and a galaxy far, far away. It's all just the same stuff. We just can't see it. That to me is a very non-controversial multiverse. That's inflation produces that kind of multiverse, because inflation takes the region of space you can see and inflates it incredibly large, but you can still only see this much of it. So inflation produces this first type of multiverse, or level 1 multiverse. So I will say that if inflation happened, we live in this level 1 multiverse. That's not a controversial idea. Now, there's the mechanism by which inflation works is it's related to dark energy, but there's this stuff that just expands. And this is the kind of the dominant model out there. It's not established, but this is the way most people think about inflation because it explains all the data that we see at this point. Is that there's this stuff, we call it false vacuum, various terms for it, but it just expands very rapidly. And as it does, it's not at a ground state, so it can decay to a ground state. And where it decays to a ground state, it forms a bubble, and that bubble will grow over time. The way inflation works to make our universe and match all the observations is that our universe is one of those bubbles, inside one of those bubbles. And so inside that bubble, we're going to have a lot of space that we can't see, some that we can. So we're going to have a level 1 multiverse in there. But if we were to step out and take a bird's eye view of all of this, there's going to be our bubble universe, but there are going to be other bubble universes populating this stuff. This is a level 2 multiverse. And so this, when most people are talking about a multiverse, this is typically it's this level 2 multiverse they're talking about. If inflation happened, we live in a level 1 multiverse. If our mechanism for explaining inflation is correct, we live in a level 2 multiverse. You can also get a multiverse by the way quantum mechanics can work. So it could be that where you have quantum events, two different copies of the universe go out from there. And again, the details of how that works out are a little more complicated, but practically speaking, let's just say it that way. And so you end up, every time you get a multiverse, or every time you get a quantum event, you spawn off another universe. So that's a level 3 multiverse. And then Tegmark's level 4 multiverse is just any other way you could get a multiverse. That's the level 4. It's a little bit of a catch-all, but it's a more mathematical region of more mathematical multiverse. And so if this level 1, level 2, level 3, that now plays in as we start to say, okay, what would the rest of the multiverse look like? That's where you start getting into these weird scenarios of, well, in our observable universe, there's a finite number of states to it. It's a very large, but very finite number of states. If this level 1 multiverse is spatially infinite, eventually things are going to start to repeat. And if we move far enough away, we're going to find something that would repeat just the way ours would. It's kind of like out of a sock drawer. I mean, if there's a bunch of socks, but there's only 10 different colors, by the 11th sock, I have to pull out a match. It's that sort of reasoning. And so these are the sorts of questions that start to come up. The challenge in that is that we'll never measure what those things out there look like. And so we're kind of speculating at that level.
When you using the analogy of socks, you're referring to the physical parameters of these various universes?
Well, so what I'm talking about there is that in say I only have 10 socks. Yeah. By the time I pull an 11th sock out of the sock drawer, it's got to match one of the ones that I've pulled out already.
Right. So one of the universes.
There's a finite number of states in our observable universe, and so that's the number of socks. The number of states is kind of the number of socks. That depending on how many times that gets reproduced, or how many things there are that size, at some point they have to reproduce. There's a question of, does ours ever reproduce? But if the explanation for us is purely physical, just flows out of the laws of physics and the way matter is, then eventually our stuff will the identical conditions of our observable universe will be reproduced out there somewhere.
Well, I feel pretty bad because I've heard it to say that there's a potential for an infinite number of universes. And if that's the case, then there's at least one universe where I was king, and I have the bad luck to be in this one where I'm just me. So,
no, you raised that's an interesting philosophical question, because we tend to think of ourselves as having an identity. So let's just say that model is correct. I think when you get into what Christianity talks about who people are, that we're a union of physical and non-physical, that we've got a spiritual and a physical component. And so in that sense, you can replicate all the physical matter of the universe however you want. You're never going to get Jeff Zweerink again somewhere. Right. But you're correct. There's this region where everything's gone along, and if it's possible, you are king. And if it's possible in a different one, you're the most famous axe murderer to have ever lived, and everything in between. If it's possible, it's going to happen somewhere. That's the kind of idea out there. But I think that raises some really interesting philosophical conundrums and dilemmas, because we think identity is pretty important. But what does it mean if you're just really a product of the laws of physics as they played out here?
And talk about morality becoming relative. That would be an absolute example of that.
Exactly.
I'll read a little quote from you from your book from several years ago, Who's Afraid of the Multiverse? You said, a large proportion of the scientific community disagrees or simply does not support multiverse theories. Some scientists argue that these models are unscientific because they offer no testable predictions. Now, I combined that with Scientific American, I believe it was, that just a few years ago had a cover article that said 10 things scientists know that you don't know. And so I thought, well, I'm fairly well informed in science. Let me look this up. And number one or number two is we live in a multiverse. So the question is that still true today, that the majority of scientists don't support the multiverse?
You know, I think, I forget when exactly I wrote that, but it's on the order of 10 years ago. And I would say in the past decade, the support inside the scientific community for the validity of a multiverse has grown dramatically. I know, I'm pretty sure 10 years ago, it was a majority were thinking, oh, the multiverse probably isn't a good explanation. I don't know what the percentage is now, but I would be surprised if the majority was not that a multiverse actually exists.
Like a level one, or some of the other more wild?
The level one is just kind of a no-brainer. I think most people think if our models of inflation are correct, and most people think they are, that very naturally leads to a level 2 multiverse. So it's somewhere even in the level 2, level 3, because those are really two different ways of producing something that basically looks the same or that's statistically indistinguishable. Whether it's some sort of quantum process, whether it's some sort of inflationary process, I think the legitimacy of the inflationary model leads to this conclusion that we live in a multiverse. I'm not a betting man, but if I were to bet, I would be inclined to think we probably live in a multiverse, a level 2 type multiverse.
Well, we'll get into the implications of that in just a few minutes, but I think you've already covered the question, is there more than one kind of multiverse? Because you mentioned that.
Right.
Is there one of those? Well, once again, I think you've kind of answered that. The next question was going to be, which one of these has the most evidence to support it? And clearly from what you said, the level 1 multiverse is the easiest to believe is there. And therefore, and you're not, are you saying you're not just comfortable with, but that you think the level 1 multiverse is correct?
Well, the way I say it is this, and this makes people uncomfortable most of the times when I say it, but as I've assessed the evidence, if inflation happened, we live in a level 1 multiverse. There's no way around that. Well, I take that back. God could orchestrate things to where the edge of our observable universe, that's just the end of it.
So no naturalistic way it could happen.
Exactly. If inflation happened, we live in a level 1 multiverse. If our mechanism for understanding inflation is correct, and that's not a single mechanism, that's the general class of mechanisms. If any of those mechanisms are correct, we also live in a level 2 multiverse. I'm inclined to think there's some legitimacy to that. I mean, we're kind of off a little bit in the speculative realm of physics here, and that's not a pejorative. That's just ideas that might be right, but we just don't have the capacity to test at this point. I mean, general relativity was speculative when it was first introduced. So this is speculative things are a natural part, or an integral part of the way science works. But I'm inclined to think that something on the order of a level 2 multiverse probably exists. But if it turns out it doesn't, I'm not going to be bothered one way or the other. That just seems to be where the evidence is going.
Well, how would the generator, so to speak, for that level 2 multiverse, you mentioned inflation, how would that actually work?
So the general idea behind inflationary models is that, and I'm going to give you a little, or if I can give you a little bit of background on inflation when it was proposed and some of the struggles it had to be accepted. when inflation was first proposed, there were a couple of problems with it. One is that the way inflation works is you've got this high energy state of the fabric of space, this false vacuum, that its natural state is to expand very rapidly, and then it will decay. And so the thought was our universe begins to exist, inflation happens, everything expands, it decays, and then you get our universe. The problem with that is that as it starts to decay, the stuff in between the areas where it's decaying is expanding very rapidly. And so those bubbles inside the decaying inflation don't ever connect and give a uniform or homogeneous universe. And so it was virtually impossible to get inflation to work and then exit gracefully in a way to match the cosmic microwave background radiation. And so it's this graceful exit problem. It also had this problematic feature in that inflation predicted generically a flat universe, but all we could measure in the 60s, 70s, and 80s was enough mass in the universe to get maybe 10 to 30% of the mass to make a flat universe. And so these were two big knocks against inflation. So with the discovery of dark matter would get it up to about 30%. With the discovery of the dark energy, that accounts for that remaining 70%. And so that removed one of the problems with accepting inflation. And the measurement of the cosmic microwave background radiation showing that it's flat, that showed, okay, inflation really does give a good explanation. But you still have this problem with inflation as it goes on, it never gracefully exits to give a homogeneous universe. In fact, you can mathematically demonstrate that in a single universe, it will never do that. And this is where Alan Guth and others came along and said, wait a second, there's another way to solve that problem, is that if this stuff inflates very rapidly, where it decays, there's a universe within that bubble. Then you get the homogeneity out of that, because as it decays, it dumps an enormous amount of energy, heats it up to a very hot, dense state, and now we've got Big Bang cosmology that flows along after that. And so inflation works and produces a universe with the uniformity, homogeneity, expansion, all the stuff that we see, and it works very well. Our universe is just now within one of those bubbles. Now, the implications of that are, I mean, you go watch a pot of coffee, you don't boil and get just one bubble. The mechanism that produces one bubble produces lots of bubbles. Well, the mechanism that produced one bubble that had a universe in it is going to naturally produce a bunch of other bubbles. And you can show mathematically that virtually every way that inflation works to produce a universe that looks like ours, it also produces other universes.
Well, since this class is advanced scientific apologetics at a Christian school, how would a multiverse impact Christian apologetics from a scientific Christian apologetics?
Mm-hmm. That's a really good question, and I'll tell you a little bit of a story. So I was, when I first started working at Reasons to Believe, the multiverse was kind of an idea that was out there, but it really wasn't talked about much. It was, it was kind of a scientifically weird idea. People, science fiction thought about that, but scientists really didn't think much about that. And there were growing, as people were wrestling with inflation, there were these ideas that maybe the multiverse was right. And so it became more popular, more people were talking about it, so I got more questions about it. And then my default answer, in fact, if you go look at the very first article that I ever wrote about this, was, oh, the multiverse isn't testable. All multiverse models can be recast as universe models. We really don't have to worry about this. Mm. And over the next couple of years, I probably gave a talk or two about that. And I was getting ready to give a talk to our staff that was going to go out as a monthly partner message. And it was about the multiverse. And I went and just kind of did some more reading to make sure that I had all the details right. And I realized that there's this level 1 multiverse that's almost certainly, I mean, if we talk about inflation, that happened. Hmm. And I realized, wait a second, there's some legitimacy to why we're talking about the multiverse. Had a little bit of this crisis of identity, if you will, because here I am, what my thought was this way, and wait a second, I can't really say that. And so this kind of sent me into about a year-long investigation of what do I do with the multiverse. And it came down to me that I realized there are these two central questions from a scientific apologetic standpoint that are relevant there. There's the cosmological argument. Does the universe have a beginning? And so as a multiverse, how does that impact that argument? And then there's a design argument. You know, things look like there's a purpose, there's fine tuning, if you will. And so I'm beginning to wrestle with that question. And as I initially wrestled with it, it looked like the multiverse was a big threat, because all of the fine tuning is, well, this is a probability of one part in X, and X can be this huge number or whatever. But the multiverse produces this large enough realm of space that almost, if you're talking about fine tuning, there are two aspects to that. There's the probability and the sample size. Well, regardless of how small the sample size, as long as it's finite, a spatially infinite multiverse will overwhelm that, and you're gonna get it. And so I realized, wait a second, that the multiverse may just eliminate the fine-tuning argument. Or rather, the way I thought about it is that the multiverse may eliminate the teleological argument. And I'm going to say it that way because I think it may eliminate the fine-tuning argument, but it doesn't eliminate the teleological argument. And I'll come back to that in just a second. And then there's this other question of, you know, when this first started coming out, once inflation starts happening, once it starts producing these bubble universes, it will never stop. So the fact it will just go on forever into the future. And the question was, if it goes on forever into the future, has it been going on forever? So is the multiverse eternal? These were kind of the two questions I was wrestling with. I actually got an answer for the second one first, because people have looked at it and asked the question, okay, it's going to go on forever. Has it been going on forever into the past? And there's actually a very powerful argument, and you can find it in one of the chapters where I describe my understanding of that argument, but it ultimately dates to a paper by Alex Vilenkin, and he had the idea. Alan Guth and Arvind Borde developed this theorem that says that if space-time on average expands, then you can show that there's a past boundary to any inflationary space-time. And so what that's saying is that if things are expanding on average, which is what inflation does, as you run time back, eventually you run into a boundary where even inflation began. And so the cosmological argument still stands even in an inflationary multiverse scenario. In fact, it becomes more robust because the space-time or the singularity theorems developed by Hawking and Penrose require general relativity to be true and require energy to behave a certain way. Well, inflation, energy violates that energy condition, and we think general relativity breaks down and we need a quantum theory of gravity. So two of the criteria for the singularity theorems of Hawking and Penrose to hold, we don't think hold. Whereas this is a far more robust, all it says is that on average space-time expands. Well, in an inflationary scenario, that's always correct. And so it's a more powerful singularity theorem. So it really does look like there's a beginning. Now, flip over to the teleological. If your argument is a fine-tuning argument, that it's one part and whatever, the multiverse just gets rid of that argument. You know, at least the way scientists envision the multiverse, that it's this, for all intents and purposes, spatially infinite region, whether it's just a level one or bunches of them out there, it just kind of gets rid of, or it does a lot to damage the fine-tuning arguments. And so I wrestled with that for the better part of a year. And you know, through some conversations with various folks, I realized that it's not so much the fine-tuning argument may go away, but the design argument doesn't. Because really what a fine-tuning argument is saying is that what we see doesn't look typical. It looks unusual. It looks like there's purpose behind it. And when you now look at the multiverse, the part of the challenge of looking at the multiverse is when you're making all these fine-tuning arguments, you're saying this is the only place where life is. What are the chances that there's other life out there? Well, in the multiverse, there's lots of different life out there if life is purely physical. You can have there can just be other regions where we're out there, all of the evolutionary scenario where it comes up. But the key distinction is there's not just the ordinary life like we're comfortable with. You can have these things called Boltzmann brains, where they're just in the random assemblage out in space. You can have atoms come together, and if our brains are just a physical assemblage of atoms with the right momenta and positions, then you're going to have this stuff this random assemblage of atoms that a brain will come into existence, realize it's there, and then poof out of existence. You now have to ask the question, is it more likely that we're ordinary life, which we think we are, which would be really weird if we're not, or is it more likely that we're a Boltzmann brain? And when you start asking that question, the vast majority of ways we can account between those two, it's far more likely that we're a Boltzmann brain. And if we're a Boltzmann brain, we're a very unusual Boltzmann brain because we're a very long-lived Boltzmann brain that sees an incredible amount of order. So it's more likely, not that all of this past history has happened, it's more likely that there was a random fluctuation that makes us just as we are today, and we're imagining everything in the past. That's a far more likely explanation than that we're a Boltzmann brain, which everything has happened, and it's far more likely than just being an ordinary life form. And so in that sense, if we want to claim that we're actual life that can trust our thoughts, that we don't get into this cognitive dissonance that we can't really trust what we think, then we still look very atypical. We look very unusual. It's like something intended for us to be here, because that's the way you end up getting us here. So you end up with this different type of teleological argument, but nonetheless, I still do think there's a good teleological argument there.
Wow. So in general terms, how would you reconcile the multiverse within a biblical framework? I think you've kind of touched on that a little bit, but in more concise terms, how would you reconcile that with the biblical framework?
So the big question that kind of led me to where I am now is, as I saw, okay, wait a second, there's scientific credibility to the multiverse. It's entirely possible that we might find that a multiverse exists. So that forced me to go back and ask the question, if that happened, what does Christianity actually say about that? And my thought was that Christianity talks about, well, this is the only universe there is. And then I started thinking about that. It's like, no, that's not really true. From a creation standpoint, God's created this universe. He's created the angelic realm, which is a spiritual dimension, not a physical dimension. But there's going to be a new heavens and new earth, which are distinct from this one. So there's this idea that there are different universes out there. That's not, I mean, the Bible talks about stuff like that. We wouldn't use that language, but that's what it's talking about. So I realized, okay, that it's not inherently anti-biblical. It also got me thinking, there's kind of a why would God do that aspect? Why would God make all these other universes when all he needed to do this? But that's the same argument we've been making. You can make the same argument. Why did God create a universe with a trillion stars when all he needed was one? Like, well, it just kind of made me realize God's economy doesn't match mine. I mean, it's a lot of work for me to create a universe with one star and one planetary system, but it doesn't tax God to make a multiverse or a single universe or a single star or one person. God can do any, so God's economy doesn't match mine. So just the fact that it's much bigger than what I expect, that's not really an argument one way or the other. What is true is if I now allow that there's a multiverse out there, my apologetic case becomes more sophisticated and less dogmatic, if you will, but such is life. I mean, I got to deal with reality, not what I want reality to be. So a lot of the things I wrestled with, I just realized, this actually aligns with Christianity well. And it gives me a way to talk about what does Christianity have to say. So for example, let's take the quantum level 3 multiverse. I find problems with that because Jesus was a being where events related to him had these quantum events. So does Jesus populate the multiverse? Well, Bible talks about how Christ came incarnate on Earth, died once for all.
Mm.
You know, that I just don't see how that language fits with there being Jesus throughout the multiverse dying in very much the same way he did here on Earth as a human. That's more problematic. So these are the sorts of things. But the cool part about that is I can now, without really having to argue for or against the multiverse with someone who thinks the multiverse exists, I can now have this conversation about, well, this is what Christianity has to say. What do you think about that? So we're talking about the gospel in the context of people being interested in the multiverse. And I would, as much as I enjoy talking about the science, really the whole point of doing science apologetics is to get people to talk about the gospel. And so that's part of where I've come to in that. It's like I don't have to argue for or against the multiverse. I just need to find out what they're thinking, explore that for a while, and then say, hey, you know, hey, Christianity says a lot to say about that. What do you think? Let's have this conversation.
To use it as a bridge.
Yeah.
Is there any evidence to support an oscillating universe?
At this point in time, we have no evidence that indicates the universe as we understand it will never stop and start contracting again. Dark energy basically assures that's the case. And we have no mechanism that has any experimental evidence that the universe can rebound off itself. Now, there are quantum theories of gravity that indicate that might be true, but we don't have any evidence of it at this point in time.
I have not seen a fully worked out quantum theory of gravity, or so.
Neither have I.
So well, you would know more than I, obviously, but I'm happy with that. For you, what do you see as the single biggest issue in scientific apologetics for Christians today?
That's kind of a broad question. I mean, if I'm honest about it, I think a lot of it is related to Adam and Eve. Are they real people? Did we breed with Neanderthals? These are the questions that get at the heart of who we are as people, because there seems to be evidence that Neanderthals and humans interbred, and that has implications for what does it mean to be made in the image of God? You know, I mean, so these are things that are hitting at the heart of Christianity, where, you know, I mean, the universe seems to have a beginning. Quite honestly, if the universe wasn't designed for us or designed in any way, that really doesn't, Christianity doesn't hinge on that one way or the other. We still see evidence pointing towards a creator, but I think these areas in the origin of humanity are the ones that will help Christians really refine what does it mean for Adam and Eve to exist, to be made in the image of God. And I think that will help us articulate. I mean, it's a challenge, but through that challenge, we will become better able to articulate what Christianity has to say.
And for the students in the scientific apologetics class, do you have any advice for them?
I would say foster a mindset where you are incredibly curious, because you will perpetually encounter areas which seem like a threat, which seem hard to study, which, why is that person interested? And what I have found as I have talked with people, and it's a piece of advice I got from a pastor, said, never argue against a position until you understand it well enough to argue for it. And that's where that curiosity comes into a place. So when somebody comes up and says something, more often than not, the first time I'm like, I don't know. I've never encountered that. I don't know what to say. Where I have developed arguments where I can come into that more prepared for battle, or however you want to say it, it's where I have gone out and studied and said, okay, what's going on here? What's the background of it? I mean, even in, you know, you held up my escaping the beginning. You know, I talked about the singularity theorems of Hawking and Penrose for a long time, never really did understand the essence of what they were saying. And as I did, I went and I understand, it's like, okay, this is talking about where the laws of physics break down because you run into infinities. And I realized, okay, wait a second, if that's what they're saying, I see why inflation no longer, when I'm talking with people about inflation, if they understand inflation, they realize that these singularity theorems no longer hold. And so I can talk about that with them, but if they know what they're talking about,
yeah,
I'm going to be left without a tool. But as I realized that, it's like, okay, so if this is what it was, now are there other singularity theorems that supplant that account for inflation? And so that curiosity has allowed me to understand where other people might object to what I'm saying or disagree, so that I can better engage them by understanding what they have to say. So ultimately, it's that curiosity leads to understanding, which helps me understand their position, which if you're talking with me, the better you understand me, the more I listen to you.
Well, thanks very much, Jeff, for being on today. You answered a lot of questions, and hopefully people realize that there's a lot more depth to these issues than is sometimes shown in the news. I can say I met you several years ago, and the time since then, if there's two things that have stood out about you to me, is number one, your knowledge. You're very, very knowledgeable, obviously, in your field. But more importantly, as a Christian, it's your humility. You admit when you don't know something, you admit when other people have good arguments, and you change according to the evidence. That, I think, for the students of the class and for other Christians who are watching, I think is as strong a testimony as for who you are as anything. Thank you very much for being on here today, and I hope I get to see you again soon, and we'll solve the rest of the problems.
Well, thanks, Don. This has been a lot of fun, and I really do hope it's useful, and I just appreciate your questions and the encouragement there. I'm glad you've identified that. To the extent I've been intentional, those are things I've tried to work on. So
excellent. Thank you so much.